Okay, next topic is in the same way what we done the problems based on differential. Here also we are going for difference equation. Okay, in terms of discrete time. That is difference equation representation for discrete time LTI system. Okay, the general form of a linear constant coefficient difference equation is going to be taken as summation k is equal to 0 to n ak y of n minus k, that is going to be equals to summation k is equal to 0 to m bk x of n minus k, where x of n is the input to the system and y of n is the output of the
Ma'am, your
system.
screen not visible, ma'am.
ಹೌದಾ? ಅಯ್ಯೋ ನಾನು ಶೇರೇ ಮಾಡಿಲ್ಲ ನೋಡ. Now it is visible.
Yes, ma'am.
Okay. Okay, difference equation representation for discrete time LTI system. The general form is going to be taken as summation k is equal to 0 to capital N ak y of n minus k, that is equals to summation k is equal to 0 to m bk x of n minus k, where n is the x of n is the input to the system and y of n is the output of the system. The integer n, capital N, is known as the order of the difference equation. The expression for the output, that is y of n of the system, described by the two components. Here also the natural response and also about the forced response. The natural response is the output associated with the initial conditions and denoted as y n of n. Okay, it is also known as zero input response. Remember this, zero input response. Then about the forced response, this is the output due to only the input and denoted as y f of n, and this is also called as a zero state response. The natural response is the system output with no input for the natural response, whereas for the forced response, output of the zero initial conditions, that is for the forced response. Next, if I go for the natural response, that is y n of n, that is zero input response. This is the output of the system with zero input. This is the output of the system with zero input. Okay, it is nothing but x of n is 0. Therefore, the general form of a linear constant coefficient difference equation with x of n is equal to 0, then what is going for when x of signal is going to be 0 means it will be 0 whole function. Therefore, summation k varying from 0 to n ak y n minus k, that is going to be equal to 0. The difference equation with input equal to 0 is known as, this equation is known as homogeneous equation. Then the natural response for a discrete time system is of the form y of n of n is equals to summation I is equals to 1 to n ci r I of n. Okay, where ri is the n roots of the characteristic equation. Therefore, after substituting of r value here, what it is going for, it will be changing as summation k is equal to 0 to n ak y of n minus k. It's going in terms of roots means r raised to minus k you will get, that is going to be equal to 0. If any root ri repeats p times, ri repeats p times, then include p distinct terms in the natural response. So we will be getting as ri raised to n, then comma n into ri raised to n, then n square into ri raised to n. It's going on, and the last term will be n raised to p minus 1 into ri raised to n. This is you have to go for. Next, when I go for the forced response, yf of n with 0 state response. The first response y f of n is the solution of the difference equation for the given input with initial conditions are going to be 0. For that reason, it's a zero state response. And it is also having two components. First one is the natural response yn of n and particular solution, same as in the continuous time what we done. Okay, then the particular solution of a given input is obtained by assuming the system output has the same form as that of the input. Example is going to be taken here. If x of n is of a into alpha raised to n, then the particular solution is of the form yp of n is going to be k into alpha raised to n. The table is giving the information when the input x of n is of only constant value, that is a, then particular solution you have to take as k only. When input is of a into alpha raised to n, you have to take k into alpha raised to n. Then if input is of a cos omega n plus pi, then the particular solution you have to take as k1 cos omega n plus k2 sin omega n. The constant k are determined such that yp of n satisfies the difference equation of the system. This is about the first response. A small note here it is given. When the input has the form of one of the components in the natural response, then the particular solution is independent of all terms in the natural response. Here small example here it is given. If the natural response consists of alpha raised to n and n into alpha raised to n, then for the input x of n is going to be equals to alpha raised to n, then the particular solution we have to take as, that is yp of n is going to be k n square times alpha raised to n. This is one example, a small note here it is given. Next about the complete response is of what? Complete response or else the total response of the system is the sum of the natural response and also of the forced response. That is, to determine the complete response, we have to go for the initial conditions and also of the input into the considerations. This is about the three parameters where we are going to learn in our difference equation, solution of the difference equation. Now we will solve the problems. The first problem, here it is given as find the natural response for the system described by the following difference equation: y of n minus 9 by 16 y of n minus 2, that is going to be equals to x of n minus 1, with y of minus 1 is equals to 1 and y of minus 2 is going to be given as minus 1. Here the conditions are given for it. This is the given equation. Here it is written as it is. Then what is the homogeneous we will be getting when our x of n signal is going to be 0. When natural response is there means x of n, it will be always be 0 only. Okay. Then after x of n is going to be 0, x of any of the x of term is going to be, it will be 0 only. Therefore, what I will be getting when I substitute x of n parameters as 0, I will be left with y of n minus 9 by 16 y of n minus 2, that is equals to 0. To obtain the characteristic equation, what we have to do? We have to replace y of n minus k with the r raised to minus k. We in the theory part we learnt of this, right? Therefore, wherever n minus 2 means how many factors are there, that is the k value, right? Here y of n will be 1 minus 9 divided by 16 r raised to, what is the term here? It's of minus 2. That is it you have to take. That is going to be equals to 0. From this you find out what is the r value. R square is going to be 9 by 16 That is, therefore, R is going to be plus or minus 3 by 4. Therefore, the natural response is going to be yn of n is going to be equals to C1 R1 raised to n plus C2 R2 raised to n. In the differential equation, in terms of continuous, it will be different. We will be writing of e power r, right? Here it is different. Don't get confused with both, okay? Then substitute for R1 and R2. We will be getting as C1 3 by 4 plus 3 by 4 raised to n plus, and C2 R2 is nothing but minus 3 by 4 raised to n. Therefore, what is y of n is going to be from this equation. If I shift 9 by 16 to LHS towards RHS, then you will be getting as y of n is going to be equals to 9 by 16 y of n minus 2. Next, what you have to do, what they given for us, y of minus 1 given and y of minus 2 it's given. First, we will go for the initial conditions, that is y of 0. Y of 0 is going to be equals to, when I substitute n as 0, 9 by 16 y of minus 2. Here y of minus 2 it is given for us, right? Y of minus 2 is nothing but minus 1. Y of minus 2 is nothing but minus 1. 9 divided by 16. What is y of n signal in this equation? From this, you will be getting as n is be 0. Any power 0 means it will be 1 only. Therefore, C1 plus C2 you will be getting off. Then this here it is written as C1 plus C2 is going to be equals to minus 9 by 16. Then substitute y of 1 in this. Once I substitute y of 1, what I will be getting? 9 by 16 y of n minus 1 minus 2 minus 1 you will get, y of minus 1, right? Then what is y of minus 1? Y of minus, here it is given as 1 only, that is 1. Therefore, 9 by 16. Then what you have to do? We have to substitute in, remember this, what I am doing here, I am substituting n as 0 in the equation of this and also in the equation of natural response equation also. In both the equation, I am going to substitute for n as 0 and n as 1. Based on that, I am writing these equations. Then when n as 1 means, here the n is going to be 1, means 3 by 4 into C1. Then minus 3 by 4, because n will be 1, right? For that reason, minus 3 by 4 into 2, C2. Solve for these two equation. If you solve, I hope you can solve of this. When you solve this, you will be getting as C1 is equals to 3 by 32 and C2 you will be getting as minus 21 divided by 32. You have to do this. These are linear equation. By using the calci also you can do, or else if you know manually also you can do. Linear equations you take off, substitute for x1, x2 and constant value. Then you will be getting your result. What is C1 and C2? It's a simple linear equations, right? You will be getting as C1, C2. Then what you have to do? We have to substitute our C1, C2 in the natural response. Therefore, the natural response yn of n is going to be equals to 3 divided by 32, 3 by 4 power n minus 21 divided by 32 minus 3 by 4 power n, where n is always greater than or equal to 0. This is one problem, and here also each problem is important for 6 marks or else 8 marks. Next problem, find the zero input response of the system described by the homogeneous difference equation. Here directly it's given the homogeneous equation, that is y of n minus 3, y of n minus 1 minus 4, y of n minus 2, that is equals to 0. With initial conditions, y of minus 1 is equals to 5 and y of minus 2 is going to be equals to 0. Solution, the homogeneous equation is directly given. You write off that. Then write the characteristic equation. Y of n is be 1 minus 3. Y of n minus 1 means the power what you have to take for r is to minus 1. If it is a plus 1, what you have to write? Then it will be plus 1 only. Okay. Minus 4 r is to minus 2, because here it is of 2 minus 2. Okay. That is equal to 0. Represent in terms of r raised to minus 2 is there, right, in terms of r square. Means what you have to do, just multiply with the whole equation by r square. If you do, you will be getting r as you can write 1 by r square, then take LCM. Which method is easy for you, you can go with that. Okay. Therefore you will be getting as r square minus 3r minus 4, that is going to be equals to 0. And solve for this roots, then you will be getting as r1 is equals to minus 1 and r2 is equals to 4. Roots are non-repeated and real roots. Yes, minus 1 and 4. Therefore, the natural response yn of n is equals to C1. Here R1 is directly here it is written. That is R1 is of minus 1 power n plus C2 4 power n. Okay. Then equation 1. Remember this, when you are going for difference equation solving, you write the equation after getting your natural response in terms of C1, C2. Write the equation in terms of y of n. Okay. Here it is written y of n is going to be equals to 3 y of n minus 1. When it is taken to the RHS, then plus 4 y of n minus 2. The initial conditions, here it is given as y of minus 1 is 5 and minus 2 is 0. Then what you have to do? Substitute n as 0 in both the equation, this equation and also this equation. Y of 0, if I substitute here, means I will be getting of what is the values for this. Means y of 0 value I will get for that reason. If I substitute, what I will be getting when n is 0, y of minus 1 will get, and here y of minus 2 will get. 3 y of minus 1 plus 4 y of minus 2. 3 into y of minus 1, what it is given? It's of a 5. Substitute that 5 here. Then y of minus 2 is 0. What you will be getting? 3 into 5 is 15. Therefore, here n is 0 means the whole value is 1. Here also 1. C1 plus C2. C1 plus C2 is equals to 15. Then y of 1 is going to be, substitute after 0, substitute as 1. When you substitute 1, you will be getting as n1 minus 1, 0. 3 y of 0 plus 4 y of 1 minus 2 minus 1 you will get. Then what is y of 0? We already calculated from this. Observe here, it's not given in the initial conditions. We calculated this, that is y of 0 is nothing but 15. We have to substitute that. 3 into 15 plus 4 y of minus 1 is of 5. Right? Substitute that. Do the calculation. You will be getting as 65. Then substitute the 1 n as 1 in natural response equation also. When n as 1 means minus 1 you will get, here 4 you will get. Therefore 65 is going to be equals to minus C1 plus 4 C2. Taken here as equation 2 and 3. Solve for the equation 2 and 3 by using your calci. It's a linear equations, right? Use the calci, you will be getting the direct results. You will be getting as C1 as minus 1 and C2 as 16. Okay. Therefore, the natural response is going to be, substitute for C1, C2 in the equation. Therefore, C1 is of minus 1 power n plus C2 is of 16 into 4 raised to n. This 16 I can write as 4 square, right? Therefore, 4 square into 4 raised to n. If I write in terms of simplified manner, what I can write? Minus 1 power n plus 1, because here is 1. When powers are going to be added, it will be n plus 1 plus 4 power n plus 2. Okay, where n is greater than or equals to 0. This is one problem. I hope you are getting. Just once you go through, you will be getting of this. Then the next equation problem. Find the zero input response of the system described by the difference equation y of n plus 9 by 16 y of n minus 2, that is equals to x of n minus 1. The initial conditions here it is given as y of minus 1 is 1 and y of minus 2 is equals to minus 1. Therefore, first what you have to write? You have to write the homogeneous equation, that is y of n plus 9 by 16 into y of n minus 2 will get. Then characteristic equation is going to be 1 plus 9 divided by 16 r power based on this value, that is r power minus 2, that is equal to 0. Find out for the r value from this. You will be getting as plus or minus j 3 by 4. Then r1 is going to be plus j into 3 by 4 and r2 is of minus j 3 by 4. Then roots are imaginary and non-repeated. Therefore, y of n power n is going to be c1 j 3 by 4 raised to n plus c2 minus j 3 by 4 power n. Then what you have to do? Then write the homogeneous equation in terms of your y of n parameter. Shift this to the RHS, this part. Then what you will be getting? You will be getting as y of n is equals to minus 9 by 16 y of n minus 2. Then the initial conditions, what you have to do? You have to substitute n as 0 in this equation and as a natural equation, both the equations. Therefore, when it is n is 0, minus 9 by 16, y of n is 0 means y of minus 2 will get, y of minus 2 is of minus 1. Substitute that, you will be getting as 9 by 16. When n is 0 means you will be getting as c1 plus c2 in this equation. Then when n is going to be equals to 1, when n is going to be equals to 1, this is for n is equals to 0. Okay, y of 1 means minus 9 by 16, y of 1 minus 2 is minus 1, minus 1 is nothing but 1, here it is given. Therefore, minus 9 by 16 into 1, that is equals to minus 9 by 16, that is going to be equals to, substitute n as 1. Therefore, you will be getting as j 3 by 4 into c1 minus j 3 by 4 into c2. You will be getting off. Then what you have to do? You have to solve for these two equations. Then here I solved in a manual fashion, substituting for each and every parameters. Or else use your calci, you will be getting of the result. Okay, you will be getting c1 as j into 3 by 8 plus 9 by 32 and c2 as 9 divided by 32 minus j into 3 by 8. Substitute your c1 c2. Therefore, y of n is going to be equals to 9 by 32 plus j 3 by 8 into j 3 by 4 power n plus 9 by 32 minus j 3 by 8 into minus j 3 by 4 power n you will be getting off. Okay, we'll stop here only. We'll continue in the next class with the different roots. Okay. Okay, we'll take in the next class only. It will be heavy if I go with one more topic.